Alright, so this will finish up section 7.4, part 2. So these are the last two problems. I'm assuming that you guys will probably get these pretty easily, but I wanted to go over them just in case anybody had any questions on them. So we have number 5, match each graph with its equation type. So what we have to do is decide, is it the midline that's being changed, or is it the amplitude that is being changed? And is it being changed with a linear equation, or is it being changed with an exponential equation? So let's just start going through. I'm just going to draw lines since all my, well, let's just say, we can do it this way. Say we have A, B, C, and D. We'll do it that way. All right, so let's look at this equation first. So it looks like to me that this is a midline change. It is not an amplitude change. The amplitude seems to be the same throughout everything, but the whole trajectory of the sine function is trending up. So this is going to be an exponential change to the midline. So this one is going to be C. Now this is where they put that midline in front, like I said at the beginning of the first video. Sometimes they tack that midline on to the front. So just be aware and notice that this one, that midline is in the front. There's a plus there. It's not being multiplied like the amplitude. So I'm going to make sure you notice the difference between those two. All right, then this one right here, this one is an amplitude change. So this is like a spring problem. That amplitude is being changed exponentially. So that one is going to be D. This one is an amplitude change also, but it is a linear amplitude change. So that's going to be B. And then this one is a midline change. And it is a linear midline change. And so this is our midline at the end, and that is a linear equation, and so this one is going to be A. All right, that's it for example 5. We'll move on to example 6. Okay, for example number 6 is find an equation for the form of y equals ab to the x plus c sine of pi over 2x. Now this is an exponential equation for the midline. So notice that that's a midline change. It's not an amplitude change. So the information that they give us here, we're given 4 different values, and really these are points that we could find on our graph, like the points 0, 4, the point 1, 22, the point 2, 100, and the point 3, 498. And this is actually how we're going to solve this. We're just going to say this is an equation. We have 3 unknowns. We have 4 points that we can plug in. Let's just start plugging in points and see what happens. So we'll start off with 0. 0 is usually good to figure out what happens. So we have y equals a times b to the x, which in this case is 0. Whoops. And what did I say? Okay, we're going to plug in y over here, which y is 4, and then ab to the x, which is 0, plus c sine of pi over 2 times 0. So the sine of 0, well, that is all 0, actually. Okay, and then c times 0 is going to make that 0, so all of this ends up being 0 here. b to the 1, b to the 0 is 1, so that ends up making a is equal to 4. So now we've already solved for 1. Okay, now we're going to use that information for the rest of the pieces that we're going to find. All right, so now for the next one, we're going to use the point. Where'd this come from? I'm going to use the point 122 for the next part. Stay away. Thank you. So we end up with 22 equals a, which is 4. So 22 equals 4 b to the first power plus c sine of pi over 2 times 1. Okay, so sine of pi over 2 is going to equal 1. So for this equation, we end up with 22 equals 4b plus c. Okay, that doesn't give us any exact values, but it kind of does help us out. So let's go on and see what happens when we plug in 2 and 100. So we get 100 equals 4b squared plus c sine of pi over 2 times 2. So sine of pi is then going to be 0. So all of this is going to cancel. So we get 100 equals 4b squared and so b squared would equal 25, and then b would equal 5. And that would be plus or minus 5. Okay, so then we will want to use our last point to make sure that we use the right value. So here, well, let's see. Yeah, we don't know what c is yet, do we? So we know that b equals either positive 5 or b equals negative 5. Okay. If b is a negative number, that means that we are going to have an exponential decay if that b is negative. So we can look at the data points that are given, and we can see that that is an exponential growth. So most likely we're going to have a positive b. But let's go ahead and use all of the data points that they give us just to confirm that. So if b, let's just give us 2 columns here. If b is equal to positive 5, then we have 22 equals 4 times 5 plus c. Therefore, c is going to equal 2. If b equals negative 5, then we have 22 equals 4 times negative 5 plus c. And what's that going to be? Negative 20, 42. Then c is going to equal 42. Okay. And then we can use this last data point that they give us. With x equals 3, then y should equal 498. So let's use that information. We have 498 should be y equals a, which we found as being 4. B, let's first test when being positive 5. X is 3 because we're testing this point right here. So let's plug in 3 for x plus c. If b is 5, then c must be 2. And then sine of pi over 2 times x, which we're using 3 as our x for this. I'm trying to prove. So we want to prove that this is true. So plugging all of that information in, that going to be 125 times 4 is 500. 5 cubed, yep. And then times 4 is 500, yes. 500 plus 2 times the sine of 3 pi over 2, which is down at the bottom. Yeah, which is exactly right. So sine of 3 pi over 2 is -1. It's on our unit circle. That's going to be down here. So sine is -1. That all goes to -1. That makes this -2. 500 plus -2 is 498. And so I don't even have to go on to my negative because that proves that we have the right one. And I was pretty sure of that anyway, just by looking at the data that they gave us and knowing that a negative value gives us a decreasing point exponential equation. A positive b value gives me a positive exponential equation. So b then is equal to 5 and c is equal to 2. And we're done.